going back to chapter 5, 5.6 talks about arithmetic sequences. So what an arithmetic sequence is, it's a list of terms that go up by a common difference. So for example, you might get a sequence such as 2, 4, 6, 8, 10. So we got our list of terms, and we got the constant difference. It's going up by 2's. So the difference is constant. We'll look at a few more examples in a second. So the word sequence is just a list of objects, and in our case, we're going to be looking at arithmetic sequences. So just some terminology here. You'll see this in a second, and we'll practice it. So once we get a list, and we'll see these values in the equation, the first term of the sequence is known as T1. So term and then 1 is just the subscript 1 just tells you it's the first term. N is the number of terms, so that is it the third term, is it the fourth term, is it the fifth one, or the sixth thing on the list? The general term Tn, and we'll look at that, is to calculate n. So say you want to calculate 5, what's the fifth term? Then you can write down T sub n. So that's how you pronounce it, T subscript n or T sub n. This term depends on the value n. So yeah, so T sub n depends on what value you are, right? So the value of the fifth term, it depends on it being the fifth term, right? So it's kind of like Tn is kind of like the y, and then n is the x, because T sub n is the dependent variable, where n is the independent variable. Yeah. Now we'll look at that in a second. So arithmetic sequence, again, we got our list, and the list is basically going up by a constant amount, and that constant amount is known as a common difference. Okay. The general term, Tn, we just talked about, T sub n, is just going to be the general term for what this value is. And there's usually, well, there's going to be an equation to calculate Tn, and we'll look at it in a bit. So if you look down here, general term and expression for directly determining any term of the sequence, symbol is Tn, for example. So Tn equals 3n plus 2. So this equation here, it's saying whatever term you're on, multiply by 3 plus 2 will give you the value of Tn. Okay, so this will be a little bit more clear once we jump into some examples. So maybe we'll look at this chart here as well. And let's just zoom in a bit and flip the page. There we go. Okay, so for this equation here, we have a little chart that they created. So T1, T2, T3, T4, that's the term 1, term 2, term 3, term 4. And then in the sequence, what the value of that term is 10, 16, 22, and 8 and 28. You can see that this is going to be an arithmetic sequence because each value is going up by 6, right? 6 more. Okay. So you can write it in this format. So sequence expressed using first term and common difference. So the first term is T1, right? 10. The common difference is 6. So for second term, it's going to be 10 plus 6. It's just 1 6 because it's just a second term. The third term, we're going to add 6 twice. So 10 plus 6 plus 6. And finally, the fourth term, 10 plus 6 plus 6 plus 6 to get what this value is, which is 28 in this case. Okay. You can also write the general sequence. So for general sequence, T1 is just T1, right? T2 is T1 plus D, the difference, the common difference, 6. Then you got T3 is going to be T1 plus 2 times the common difference, and then T4 is going to be T1 plus 3D. So hopefully this kind of makes sense, and we'll look at this. Okay, so this blue box is kind of important thing that we're going to look at in this section or this page. So the general term of arithmetic sequence is Tn equals T1 plus n minus 1 brackets times D. Okay, so let's just go over this. So T1 is just going to be the first term in the sequence. N is the number of terms, so what term we're looking at. We got D, which is a common difference, so the pattern, the consistent difference between each term. And T sub n is the general term in of that number, right? So if we're looking at whatever the n value is. So we'll look at a few examples of these. Okay. You're not going to really have to graph this, but if you do graph it, we're looking at straight line relationships. Why is these arithmetic straight lines, like slopes? It's because there's a constant difference, right? So each value to the next value, there's a pattern going on. Those are the ones we're going to be looking at. So that's why it's in this chapter 5 and ties in with all the linear equation stuff that we've been doing. Okay, let's look at 3 different examples. Maybe after the examples, it'll be a bit more clear. So a visual and performing arts group wants to hire a community events leader. The person will be paid $22 for the first hour, 37 for the second hour, and 52 for 3 hours of work, and so on. So you can see that we got it's an arithmetic sequence. We got 3 terms here, the first term, second term, and the third term. And I know it's an arithmetic sequence because we can calculate the common difference. So the common difference would be just 37 minus 22, which is going to be 10, 15, 15. So 15 more to get to 37, and we could check that with 37 plus 15 you get 52, right? So let's look at the part A. So write the general term that you could use to determine the pay for any number of hours worked. So we're going to write it in this format here. Okay. So state, like we just mentioned, T1 is 22, T2 is 37, T3 is 52. Okay. And then you subtract one term from the previous term to get 15, right? So that's kind of the information before we start. So solution to A, for the given sequence, we kind of calculate that. T1 is 22, right? So we already have this variable T1. We have D, right? And you can leave N kind of how it is, and you can leave Tn how it is because we just want it in the general formula. So you just plug it in. Tn equals T1 plus N minus 1D, the formula. Plug in the value 22 and 15, and then now just simplify. So 15 times N gives you 15N. 15 times negative 1 gives negative 15. Negative 15 minus 22 gives you the 7. So 15. So Tn equals 15N plus 7. So they wrote it down here. And that's all you need to do for that section. So B, what will be the person get paid for 6 hours? So remember N represents the number of hours. So if they're asking you what this T sub N is for when N is 6, so we just plug in a 6 here. 6 times 15 plus 7 will give you the answer. And then that's kind of the work that they did here. And you get $97. So that's how much they get paid. Okay. So the value of the 6th term is 97 for 6 hours of work. So method 1. We're only going to do method 1. We're not going to do the graphing section, but you can do that as well if you have a graphing calculator. Let's look at example 2 here. So we're going to do something similar. We're always using, by the way, this equation here. So you need to write this down or memorize it. You can just write it down. Tn equals T1 plus N minus 1D. And again, D is common difference. T1 is the first term. Tn is the term at the nth position, I guess. And N is the number of terms that we're looking at. So if we're looking at the 5th term, then we're going to just plug in a 5 here, and then we can calculate it. Okay, example 2. Determine the number of terms. The muskox and the caribou of northern Canada are hooved mammals that survived the Pleistocene, I'm probably pronouncing it wrong, era, which ended 10,000 years ago. In 1972, the Banks Island muskox population was approximately 3,800 animals. Suppose that in the subsequent years, the growth of muskox population generated an arithmetic sequence. So already you know that this is probably going to be the T1 because in 1972 that's the starting position or starting number of animals, and they're saying it's growing as an arithmetic sequence, meaning it's growing by a constant amount as well. So far we got from that information. So in which the number of muskox increased by approximately 1,650 each year. How many years would it take for the muskox population to reach 83,000? So we got our T1 here. We got our common difference already. We don't need to calculate. It told us. So D equals this. And they're saying like at Tn, T sub n is going to be 83,000. Now we have to calculate the n value. So how many years? So it's a little bit different than the previous example. Previous example, we just had to find n. Now we're going to find, previous example we had to find Tn. In this example, we have to find n, right, in the formula. So first thing you want to do with these questions is list all the information you got down. So we mentioned T1 equals 3,800. Common difference it says is D, 1,650. And Tn at a certain number of years, they're going to get up to 83,000. Okay. So now what do you do with these terms? You just plug it into the equation. 83,000 equals 3,800 plus n minus 1 times 1650 times the d. And you're just going to do a bit of algebra. So multiply it in, right? And then once you get down here, you're going to have to isolate the n, divide by 1650. And then n is going to equal 49 years, right? The thing about to note this is not 49 years later, because it includes the first term as well. So the year 1 is already included in this 49. So it's a year 1 is 3,800, and then 48 years later, it's going to be 83,000. So that's kind of what they did here. So there are 49 terms in the sequence. The 49th term represents 40 years after 1972 or 2020. It would take 48 years for the Moscow's population to reach 83,000. So yeah, n is 49, but it's 49 terms, right? In the sequence, it's 49 terms, but it's 48 years after the first term to get the population to be 83,000. Okay. Yeah, we'll do one more example, and then hopefully this makes sense. All we're doing is, again, playing around with this formula. Arithmetic sequences go up by a constant amount. Make sure you know what Tn, T1, and D is, and that's all we need to know for now. Okay, example 3. A furnace technician charges $65 for making a house call, plus $42 per hour or portion of an hour. Okay, so just to make a call, I guess just to show up is $65, and then $42 per hour after that. Okay. So generate the possible charges, excluding parts for the first 4 hours. So here we can see this is going to be an arithmetic sequence as well, because it's going to start at 65, but then after that, every hour is going to go by a constant difference. The constant difference is going to be 42. So here D is equal to 42, right? And then T1, the first term is actually going to be, what's going to be the first payment or first hour of work? The first hour of work is going to be the 42 plus the 65, right? Because 65 just to show up. So T1 is going to be 65 plus 42, which is 107. D is going to be 42, right? And then I think that's pretty much all we can do right now. And then Tn and N is just going to be left alone. So write the sequence for the first 4 hours. One, and they wrote a table here. So 1, 2, 3, 4. So numbers of hours worked. 1, 2, 3, 4 as well. And then again, 107 because 42 plus 65 gives us 107. And then thereafter, the furnace technician just makes $45 more. So you just add them on top of each other. The charges for the first 4 hours are 107, 149, 191, and 233. Okay, B. Determine the general term Tn for the sequence. How do the values in the general term relate to the situation? Okay, now we're just going to plug in the two values that we found. We found T1 to equal 107. We found D to equal 42. So we're just going to plug it into our general equation that we have. All right, 107 here, 42 here, and then you just simplify as much as you can. So 42 times n, 42n, 42 times -1, -42, the 107 for the T1. Subtract -42 from 107, you get 65 and 42n. So Tn equals 42n plus 65. So now we have the equation, so we can figure out if you work 5 hours, how much does it cost? 6 hours, 7 hours, 20 hours, 100 hours. You just plug it in for the n, and you solve for Tn, right? T sub n. So the constant term 65 represents the initial charge for a house call. The numerical coefficient 42 represents additional charge per hour. Okay. And method 1. So for C, what is the charge for 10 hours? You just plug in 10 for n, and that's all you need to do. 42 times 10 is 420 plus 65, 485. Okay, and you get your answer. The other method is to do graph it, but we're not going to use the graphing calculator for this section. Okay, so hopefully this section kind of made sense. Going over the key ideas we went over in this section. A sequence is an ordered list of elements. So, and in our case, we're looking at arithmetic sequence. So arithmetic sequence is just a special sequence that goes up by a constant amount. Elements within the range of sequence are called terms of the sequence. So each value is a term. So the first term, second term, third term, etc. To describe any term of a sequence, an expression is used for Tn where n is a natural number. This term is called general term. So Yeah, so the Tn, well, let me just flip back. This is going to be the general term here, right? Tn equals T1 plus n minus 1d. Okay. In an arithmetic sequence, each successive term is formed by adding a constant. This constant is called the common difference. The general term of an arithmetic sequence is right here. You can find down here, and then it talks about n, d, t, and n again, t sub n. The graph in an arithmetic sequence is a discrete linear relation with a constant rate of change equal to the common difference. So all you need to know here is it results in a slope. Okay, because of the common difference. If it wasn't a common difference, then you'd get more funky, weird shapes. Okay, so that is section 5.6. In 5.6, I think I mentioned you need to do number 1. I think I said 1 to 7. So 1 to 7 to do that. Some of these questions won't take too long. So let's look at number 1. Decide whether each sequence is arithmetic. So remember, to be arithmetic sequence, it has to go by a constant amount. For each arithmetic sequence, state the value of t1, the value of d, and the next 3 terms. Okay. So is this arithmetic sequence for A? It's going up by 16. 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 And it's a list. So it looks like this is arithmetic sequence for A. Yes. T1 is 16. The common difference, the value of D is going to be 16 as well, because it's going up by 16. And then next 3 terms is going to be 16 plus 80, 96, and another 16, another 16, and then you get those next 3 terms. Okay. Let me know if you have any questions. Was this section confusing? If so, give me a message and I'll try explaining it in a different way. And we'll take it from there.